So one of the ways that logarithms are used are with decibels, with measuring sound. And so it gives us here the definition for decibels. The loudness D, so D is for decibels, measured in decibels. Decibels is the unit. Okay, so the loudness, though, is D. And the abbreviation for decibels is little d, capital B. So the loudness, measured in decibels, is of a sound of intensity I. So I is the intensity of the sound. That intensity is measured in watts per square inch. Again, that's the unit of measure. And they give us this formula right here. So it says D, the loudness, is equal to 10 log, now that's a common log, I, so this is an I right here. It looks kind of like a 1, but it's an I, over 10 to the negative 12th power. Okay, so an example where we're going to use a common logarithm. All right, now it says in example 9, what is the decibel level of one of the new quiet dishwashers with intensity 10 to the negative 7? So that's going to be your I right there. And then and it's measured in watts per square inch. And then we're going to figure out the decibels. So D is going to equal 10 log, that's a common log. My I is going to be 10 to the negative 7 over 10 to the negative 12. Okay? So that's how you plug it into the formula. You're replacing the I into the formula because they give us the intensity. Okay, now in the parentheses we're going to use our laws of exponents, our rules of exponents, and so we can subtract 10 to the negative 7 minus negative 12, or that's going to be 10 to the 5th. Okay, now we have an exponent rule that says if you have log base a of a to the x, that just equals x. Well, when it's a common log, if you have log base 10, base 10, it's a common log. So log of 10 to the x, that's just going to equal x because it comes from that rule up here. And so this part right here is just going to equal 5. So I'm just going to have 10 times 5, and that's going to mean then 50, and that's in decibels. Okay, so that's the answer.